Okay, a pipe is open at both ends. A first harmonic standing wave is set up in the pipe. The diagram shows the variation of displacement with distance in the pipe at t's equals 0. The frequency of the first harmonic is F. All right, good enough. Good to know. All right, so notice that this is displacement to the right. This is displacement to the left. Okay, so what that means is that this air particle right here is displaced a lot to the left. This guy is a little bit to the left. This one's a little bit less to the left. This one's even less to the left. This guy's not displaced at all. And then notice that this is now displacement to the right. So a little bit to the right here, a little more to the right. Sometimes helps to draw like what it's doing there, right? By the way, so this center, this little spot right here, at this moment, is actually a rarefaction because this end is pulled away from it, this end is pulled away from it. Half a cycle later, that's going to be a compression. Let's hold on to that thought. You know, I don't think they ask about that, but we'll go with that. Okay, so sketch on the diagram the variation of displacement with the particles when t is, so t equals 0 looks like this, right? And then you're like, ah. I think my brain just did a full stop when I saw this, okay? But they're putting F in the denominator there. So really, t is going to be 3/4 of the period, won't it be? We can deal with that. We can do 3/4 of the period. Because remember, period is 1 over F, right? So they put F in the denominator, which is, to me, just made my brain do a full stop. But then I thought about it for a little bit, and this is what's going on, right? Okay, so, you know, how does this thing vary? Well, right now, at t equals 0, it's going to look like this. Okay? At t is, and t equals 1/4 the period, just breathe, right? We can do this. It's going to be flat, right? At t is 2/4 of the period, it's going to be totally inverted because it's halfway through the cycle, right? It'll be like that. Only imagine that the center is actually, anyway, yeah, I kind of screwed that up. Okay, so then what is t is 3/4? What's that going to look like? Well, isn't it going to just be this guy, right? And then at t equals, and then, I'm sorry, t, there should be a period there, right? At t is 1 cycle, it's going to look like this again, right? So it goes this, quarter cycle later it's this, half a cycle later it's this, 3/4 of the cycle it looks like that, okay? So sketch on that. That's, eventually I figured that out and I felt very confident. Okay, an air molecule is situated at x in the pipe at t equals 0. Describe the motion of this particle for 1 complete cycle. So notice that it starts off displaced to the left. Okay, so here it is, right? It's displaced to the left. It'll go through the center. It'll be displaced to the right. It'll go through the center, and it will come right back. So talk about that. Just, I laid out this whole elaborate thing and gave all the velocities and everything like that. And then you look at the mark scheme, it's like, oh, it just goes back and forth. All right.